Hey, Mr. Lineski here. We are in Unit 8, Section 2. We are getting into trig. We're going to look at some trig ratios here, one of them being tangent, or tan, and our wonderful fake tan. Alright, so before we start talking about the trig ratios, it is important to understand something called a reference angle. Keep in mind we are dealing specifically with right triangles, so we're always going to have a right angle in every triangle that we do here. So when we are determining trig ratios, you have to find something called a reference angle, and then from that reference angle you're going to label the opposite and the adjacent sides from that reference angle. So here I just have a simple right triangle, triangle ABC, and let's say that angle A is the reference angle. So I always recommend putting a little mark wherever your reference angle is. So if A is my reference angle, we want to label the sides that are opposite and adjacent to that angle. So keep in mind our rule for opposite. The trick is if you kind of put the tip of your pencil inside the angle and just sort of lay it down across the paper, it will cross through the opposite side. So we can say that this would be the opposite side. And the word adjacent sort of means the side that's sort of next to it, that's sort of creating this angle. And so that would be the adjacent. Keep in mind that this third side here, opposite the 90-degree angle, is always the hypotenuse. So the three words that we're going to be seeing here today are opposite, adjacent, hypotenuse. It's really important that you know how to label those three sides on a triangle given a reference angle. So notice if I change the reference angle to angle B, same triangle, triangle ABC, my opposite is now this side. This is opposite angle B. This is still the hypotenuse because it's opposite the 90-degree angle, and now this becomes the adjacent. We will never, ever use the right angle as a reference angle. It is specific only to the hypotenuse, and so we can't really label opposite and adjacent when we know it's already called the hypotenuse. So your reference angles are the other two angles that are sort of left over. Alright, so what exactly are trig ratios? Trig ratios is when we take a comparison of two sides of a right triangle. There are three basic trig ratios that we are going to use in this class. There are others that you may see as you progress through high school. But the three that we are looking at are called sine, cosine, and tangent. We abbreviate them as this, and you may have seen these buttons on your calculator before. However, we don't call it sin, cos, and tan. It's still sine, cosine, tangent. So please make sure you are referring to them as such. Keep in mind, for all right triangles, it works just for right triangles, the following trig ratios are true. So keep in mind, we're comparing two sides. Keep in mind what our sides look like, opposite, adjacent, and hypotenuse. So if I have the sine of angle A, some reference angle, the ratio is then the opposite side divided by the hypotenuse. Cosine of A follows the ratio the adjacent side over the hypotenuse, and the tangent of angle A is opposite over adjacent. It's kind of an easy little way of remembering this. It's kind of like a little saying that teachers have used for a while. It's called Sohcahtoa. Some people think of it as like you soak your toe. I don't know, weird, like soaking a toe. But so comes from sine, opposite, hypotenuse. Ca comes from cosine, adjacent, hypotenuse. And tangent comes from opposite, adjacent. So, before you start these problems, and this is not written in the notes, so you may want to jot this little bit down here, you always want to start a problem by marking your reference angle. So these problems here, we're not actually solving for anything, we're just going to set up the ratio. So we're not solving, just setting up the ratio. So if I ask you, what is the sine of angle A? Well, angle A is my reference angle, so put a little mark at my reference angle. And so now the sine of A, from my reference angle, it's important to label my sides. So this is what that looks like. If this is my reference angle, this is opposite, this is adjacent, this is the hypotenuse. So the sine of A is opposite divided by hypotenuse. So the opposite side is 5, and then divided by the hypotenuse, which is 13. And then we just leave it like that. We leave it as a ratio, we don't get the decimal, and again, we're just setting these up for right now. So now if I said, well, what's the cosine of angle A? The cosine of angle A, here's angle A, my reference angle. Cosine is adjacent divided by hypotenuse. So cosine would be 12 divided by 13. So now what happens if I switch my reference angle? So now I'm switching it over to sine of B. So my reference angle is B. So this now becomes opposite. This is still hypotenuse. Hypotenuse is always hypotenuse. And then this side becomes, whoops, the adjacent. So sine is opposite over hypotenuse. So opposite is 12, hypotenuse is 13. Tangent of B, tangent is opposite over adjacent. So opposite is 12, adjacent is 5. So that's what that looks like there. Here's just sort of a little try it situation for yourself. So if you either want to pause the video and just try these problems out, again, you're just simplifying them, you're setting up the ratio, and then it is important to simplify your fraction. So you're not solving anything, just kind of setting it up. Alright, so let's take a look at problems. So there's a really, really important aspect of this, and you may not be able to follow along with me at home necessarily if your calculator doesn't do this. But we all have the graphing calculators in the classroom. Before we start solving right triangle problems, we need to make sure that our calculator is in degree mode. So on these calculators, there's a thing right here that says mode. When you push that, it will pull up a big list of things. And if you take a look right here, if you can see it, it says degree and radian. We're currently in radian mode. We need to switch that over to degree. So just kind of slide it over, press enter, and then second mode quits you out of it. So we need to be in degree mode. That's going to make a big, big difference on how we actually solve these problems. Okay, for this problem here, we're given an angle. So notice we have our 90-degree angle, and then we're given that this is 7 degrees. So I recommend that any given angle become your reference angle. So I'm going to call this my reference angle. Now I'm going to label my sides like a good student should. So this is opposite my reference angle. This is adjacent, and this is hypotenuse. So now they want us to solve for y. Solve for that y right there. So based on what I have a number here and I have a y, a variable here. So I can set this up and say opposite hypotenuse, and I'm just going to reference this up here for us. Sohcahtoa. So I'm going to set this up as opposite hypotenuse. That's sine. So I would say sine of 7 equals opposite over hypotenuse. And so now things like sine, cosine, and tangent, when you put them into your calculator, it acts like sort of a function almost, that it's sort of like a square root. It does something special to this number. And so now if we kind of pretend like this was just a regular algebra problem and ignore the sign, pretend like it wasn't there, and I said, how would I get y by itself? Hopefully you would say, we'll multiply both sides by 5. So when I multiply both sides by 5, these cancel out, and now I'm left with y equals 5 times sine of 7. And just to show you on the calculator, here's sort of how you would type that in. 5 times sine of 7. And when you hit enter, that gives you your answer. So rounded to the nearest tenths, I believe, this thing is equal to 0.6. So the length of this side here would be 0.6. This problem here I'm going to leave as open for you to kind of try out on your own. The next problem here, there are two variables, so we're going to take a moment to solve for both of these variables. So here's 26 degrees. I'm going to mark that as my reference angle. So if this is my reference angle, I'm going to make Z opposite. That's going to make 14 adjacent, and that's going to make W my hypotenuse. So now I have to solve for both variables. It really doesn't matter what I start with, so let's just solve for W first, the hypotenuse. And so here we have that 14 is the adjacent, so which trig function uses adjacent and hypotenuse? That's cosine. So cosine of 26 is equal to adjacent divided by hypotenuse. And so now this one's a little bit more strange to solve for. We need to get the variable out of the denominator. So in order to do that, we have to multiply both sides by W. So now these cancel out, and now you have W times cosine of 26 equals 14. To get W by itself, you now have to divide both sides by cosine 26. So not just 26, you have to take the cosine with it, kind of like they're matched pair together. And so then in your calculator, you would just type in 14 divided by cosine of 26. And when you type that in, you get an answer of about 15.6. So the hypotenuse here would be about 15.6. To solve for Z, I recommend using the stuff that was originally given to you. You could, if you really wanted to, use the 15.6 now, but on the off chance that you mess it up, you're better off just sticking to the stuff that was given to you. So I'm going to do opposite and adjacent. That's tangent. So reference angle is still 26. So tangent of 26 equals the opposite over the adjacent. So just like we did on the last problem, multiply both sides by 14. So this is what I would type into my calculator, 14 times tangent of 26. Again, if you don't have this calculator at home right now, no big deal. And when I solve that, I get an answer of about 6.8. All right, the last problem I believe I'm going to do for you is this one here, where instead of solving for a side, we're going to solve for an angle. So I actually want to solve for the reference angle and round to the nearest tenth. So here's sort of your notes for this part. Anytime you're solving for a reference angle, or just the angle in general, you're going to use a special feature on the calculator called the inverse ratios, which are sine -1, cosine -1, tan -1. Or sometimes we refer to them as just inverse sine. So based on my reference angle, label the sides, opposite, adjacent, hypotenuse. Kind of tough to see these numbers here, but that's 13 and 19. So now based on what I have here, I have adjacent and hypotenuse. So the trig function that uses adjacent and hypotenuse is cosine. So I'm going to say cosine of P equals 13 over 19. And just like in the calculator, when we had problems where it was x squared, and we wanted to undo x squared, like if we had x squared equals 9, to undo that, we square rooted both sides. Well, now we want to solve for P, so to undo cosine, we're basically going to do inverse cosine to both sides. And so what this ends up looking like in your calculator is P equals this. And so how you get that on the calculator is you hit second and then the cosine button, and that pulls up your inverse cosine. And now you just type in your fraction, 13 divided by 19, and that will tell you how many degrees the angle is. So 46.8 degrees. So we can say that P equals 46.8 degrees. All right, the other problems that are left on the paper I would like you to try out on your own. All right, thank you for watching.